This is Angelica Madsen's exam 5 test corrections for physics. The first problem that I got wrong was number 1. It says your electromagnetic wave is traveling towards the west. At a certain moment, a direction of magnetic field vector associated with the wave points vertically up. The direction of the electric field vector of this wave is, and then you had to decide which direction it is pointing. And I kind of explained it in words. So using the right hand rule, your fingers are going to point up with the magnetic field, which says that it's coming straight up, so not necessarily north, south, east, and west, just vertically straight up. And then they're going to curl towards the west. Yep. So basically your hand is going to be like this, and it's going to curl towards the west. And I guess you're kind of looking from right here. And if there's a plane with north, south, east, and west, my fingers are curled towards the west. My thumb is pointing south, which means that is where the electric field is pointing, and that is the correct answer. Problem number 2, in a series RLC circuit, what quantity is maximum at resonance? And I kind of gave an explanation of what I found on resonance. I know it's not what it says in our notes, but this is what I found real fast. It says largest possible response to a signal, especially when its inductive and capacitive reactants are balanced. So the correct answer to that is the current is at its max. And let's see, the next one that I got wrong was going to be number 4. So it asks, a capacitor is connected across an oscillating EMF. The peak current through the capacitor is 2. What is the peak current if the capacitance is doubled? And I made this way too complicated when I was thinking about it, but basically the capacitor and the capacitance are related directly. So if you double the capacitance, the capacitor is doubled, and 2 times 2 is 4. So the correct answer is 4 for the current. The next problem that I got wrong was number 5. It says which one of these phasor diagrams shown below best represents a series LRC circuit driven at resonance. And the correct answer is 3, where they all have the same values at each point. And as stated up here, resonance is when the capacitant and inductant, they're balanced pretty much. And so you see here in this that they are balanced, unlike the other graphs. Alright, the next problem that I got wrong was number 6. I was looking it up on how to do it and trying to figure it out with my notes, and I came to the conclusion that this equation is correct, but somehow in my math I plugged something in wrong. But the correct answer is 256. The next problem number 7. So basically we're trying to find the intensity of a wave. I'm not sure what I was doing right here, because we don't know what E is or C, so that wouldn't work. But what I was doing to solve it was I was using the units, and we know that the B field, or the peak electromagnetic wave, is in T, and so T, and then to get to what we need A over M is our units that we're looking for. So I knew that by using, what is it called? I believe it's mu naught. Let me see. Alright, so it's right here. So on our test notes, so mu naught is equal to this with this unit, and so looking at that unit, using mu naught gets rid of that t for us, and also gives us the a and the m where we need it. So t over the t dot m over a, the t's cancel, the a flips up, and it becomes the units that we need. And the correct answer is 2.98 times 10 to the negative 5. For some reason, when I keep plugging it in, I get 0.000398 AM. So it is literally 0.0001 off, and I'm not sure why. But that is the correct answer, and that is how I got to where I got. The next one that I did wrong was number 9, and it's really sad because I remember going over this, but basically I did the problem right. I just forgot the 2 pi underneath in the denominator, and when you fix that, you get to the 503, which is the correct answer. And let's see. The next problem that I wanted to go over was problem number 12. So this one, I was actually really proud of myself because I did a lot of it. I got part A right and part B right. Part C, I just switched and used the wrong equation. I'm not sure where I got the I frequency L, but the correct equation is V is equal to L di dt. And when you plug the values into there, you do get the 179 volts. And then the next part of it, you're looking for the average power loss in the system. I was using P is equal to IE. Once again, just using the wrong equation. For this one, you wanted to do P is equal to I squared R. And when you do that, you do get to the 161 watts. And I kind of put a note down here. It says no power loss in an ideal inductor. It just stores energy and releases it, pretty much. Alright, well that is it for my test 5 corrections.